Okay, so I've gone ahead and set up the different views for this question. So if you're looking at this and you're unsure how I actually got my 90-degree angle set up out here, go back and look at the previous video. Okay, so as I said, in my true shape up here for this surface, I'm going to draw the elevation of the object. Okay, and in this view, this is where the actual measurements are used. Okay, so I've just made up my measurements for the object, mark them across, mark the heights. Important thing to remember, this line here essentially represents this line here, which in reality would be horizontal. It's basically an edge view. It's kind of like an XY line. It's like an edge view of the floor coming out as this way. Okay, so this is essentially where our horizontal lines have become. So in other words, if that's the base of the object, all the other lines up there need to be parallel to it. Okay, any surfaces that are parallel to the base will be parallel to that line there. Okay, the wall or the back surface there, these edges here are parallel. Okay, in the basic version of axonometric, where we have an equilateral triangle here, when you set this up, this angle here will end up being at 15 degrees. Okay, and this angle over on this side will end up being at 15 degrees. Okay, so if you have an adjustable set square, it's handy to set it up that way. It doesn't make any difference with the dimetric and trimetric projection. This angle will be at a different angle, but it doesn't make any difference. Any surfaces that are parallel, those lines will be parallel to that. Okay, so I went and measured out my distance and set that up 15 degrees, or as I said, if it's a dimetric or trimetric projection, parallel to that edge. Those lines are going parallel. Those lines there are parallel. Okay, and parallel to that, and parallel to that. Okay, so this is always going to be an elevation. Okay, front elevation, end elevation, and this is going to be an elevation. Okay, so I've put in the three different views, but in reality, in a question, you're going to be using two different views, but I just want to show you that it doesn't make any difference. So elevation, elevation, and plan. Okay, obviously the orientation of these things are important, but you'll see that from the actual question. All right. Important thing to notice on this, or to know on this, I suppose, from a point of view of figuring out certain measurements. Okay, we're looking in this direction to get this view. Okay, we're looking down this direction to get this view. We're looking in that direction to get that view up there. Okay, but where you're looking at these views in relation to each other is also important. Okay, so if I take my various colors here, so to see the plan, I'm looking down on top of the elevation that way. Okay, I'm looking down 90 degrees to the top of this to see this view. Okay, that's important from the point of view of where there's curves and stuff, actually setting up distances and marking them on the elevation and marking them on the plan. Okay, to see this view, okay, I'll put that in as the green. If I go back down to my plan to see that view, I am looking that direction, like that, to see this view. So as I stand looking in like that, I see this view up here. Okay, for my elevation up here, on the red wall, okay, in terms of the plan, I am looking in that direction, like that, to see this view. In terms of this elevation, if we didn't have a plan and we're just working with two elevations, I am looking in that direction. I'm looking that direction to see this view over here. Okay, and I said that's important in terms of heights. So, or width. So in other words, my heights here of 25 and 25 are the same 25 and 25 over here. Okay, my width of 70 that I used across this, okay, because I'm looking down on this to see this is also 70 here. Okay, so that's just, if you can understand the relationship between the three different views and how they work in terms of the way you're looking at them, it does make a big difference from the point of view of figuring out measurements before you start at your actual 3D here at the center. Okay, so after that, I've gone and indexed the back surface of this, A, B, C, D, E, F. Okay, the back surface of the object. So as I look down top of it, F and A appear at that point, E and D at that point, C and B at that point. I also index them up here in this view. So again, looking in this direction or this direction to see this view, B and A appear at the bottom edge, C and D appear there, E and F appear there. Okay, and again, it's just E is seen before F, that's why it appears before, the same with C and the same with B. Okay, so there's my 3 views indexed. After that, next important thing, and this will follow through for all the questions, whatever angle this axis or this line is projected out at, it's the same angle that any points on this view will come back to the center of the room, back to the 3D at. Okay, so for this question, because the basic setup, that's going out at 30 degrees, so any points I want to bring back are going to go back at 30 degrees. Okay, so even if I follow points, a point I have already, point A is projected back here at 30 degrees. Okay, point A here is projected back at 30 degrees, so straight away I know point A is there, right at the corner of the room, which would make sense because I've got this object shoved into the corner of the room. That back corner, lowest back corner A, is going to appear at the center or corner of the room. Okay, sorry, yeah, the inside corner where the 2 walls and the floor meet. Point A there, straight up. So I know that point A is located right there. Okay, if I work my way around in terms of B, C, D, E, and F, I might as well follow the points. So B is projected back, in this case at 30 degrees, but I said if it was a different question, it would be projected back at whatever angle this is projected out at. Okay, which will be different depending on the question. Okay, so B is projected back along there. B is projected straight up from the plan. Okay, and the plan always goes, because this y-axis, or that axis there, is always vertical, the plan will always be set up like this, and these points will always be projected down vertically to the plan and then back up vertically from the plan. Okay, so that corner right there is corner B. Okay, once you understand that, the drawing of the rest of them is quite simple. So C, I'll bring C from here, and just to show that it doesn't make any difference which views you go from. Okay, so I know C is straight up here, that's where it crosses the line from C. I know that's going to be C, but I could also have taken it down from this view up here just to show you we can work with these 2 views, and it intersects at the same point. Okay, so that is the location for point C. Okay, even at the moment I'm joining in the same order. Indexing is important. Obviously, if you can do the question without indexing and get the right answer, brilliant. I find indexing, even though I suppose you could argue that it slows things down a little bit to put them in the first place, I think it will speed you up in terms of not going wrong when you start joining points. Okay, so D is back along there. D is up along there. Okay, so there's the location of point D. C is joined to D. Okay. E. So I'll just very quickly finish this off. And what I'll do is I'll use the 2 different views. So that's E coming back from that again. I'll use the 3 different views. E coming up from there. And E also coming down from this view to show you that they'll all end up in the same place. There's a location for E. Okay, E joins to D. So that will always follow. If D and E join together, D and E are still going to join together. E joins as far as F. Now if I want, I can actually see that E is actually, F is going to be right there at that point. Okay, but just to project it down from this view, there's point F. There's that point. Okay, so the back surface is against the green wall. There it is there. Okay. Now, I will have already brought out some of the lines that I'm going to need for the thickness coming out this direction. Okay, so my points on the front of the object, if I want to index them, are going to be the same again. They're just going to be brought up, but they're going to be on the same lines that already come back. So I'm just going to extend these guys out because they're going to project out from the same location on this view. My points at the front are directly in front of the points I have there already. Okay, so I'm going to project out D. And again, even though this is a very basic shape, it is still the exact same idea. And if you can grasp that idea, it works the same for all the other questions. So that comes up there. And that's sitting there like that. My back corner runs up there in line with A. And that's going to join from there as far as there. Okay, this one can go in heavy like that. C as far as this. Okay, this point, straight up there. That's the same point which is in line with D back there, which is going to finish at that location. This edge runs across here. Okay, the point in front of E runs straight down along here. There's the same point running straight up. And as you do this, you'll find that lines that you've already projected for a different part of a different couple of points in the question will end up lining up with new points. Okay, so that's my back corner there, which is going to come down along here. And that goes straight up there and back as far as there. I'm ending up with a couple of little double lines here where I'm trying to keep my head out of the way of the camera. But that is the object. Okay, and as I said before, if you want to just go through it nice and slowly, look back at the previous setup. The principles are the exact same for any of the other questions. The important thing being the projection lines are coming back 90 degrees to each of the edges or sides of the triangle. That's the important thing. The corner of the 90-degree triangle will always line up with the point of intersection of the three axes, or the corner of the room as I call it. Okay, that will always be the case. Okay, and you will always have a 90-degree angle here, here, and here, whichever two views you're using. Okay, that's basically it. These measurements here should be shortened slightly. So if your object at the center here, your isometric, ends up being in some way bigger than where you started out, there's something off a little bit. Okay, so I hope this helps. If you have questions, please ask. If you like the videos, please subscribe. You'll get notified when I upload new videos. And I said next up, I'm going to do a actual ordinary level question of the mocks of 2020 and a higher level question of the mocks of 2020 as well. Okay, thanks for watching.